Hi, how's it going? Welcome to Code with Z. In today's video, we gotta remove duplicates from this array in place. Why? Well, because that's what LeetCode 80, remove duplicates from sorted array part 2, is asking us to do. As you can see, it says, given an integer array called nums, like this array that we have here, sorted in non-decreasing order, meaning it's sorted in increasing order, remove some duplicates in place such that each unique element appears at most twice. The relative order of the elements should be kept the same. Okay, let's see how we can solve this. Well, our approach is going to be really simple. Our code is going to be literally like 4 lines or so. So let me visualize everything for you. But the first thing that we need for our approach is going to be a variable called I. And then we're going to have a really simple loop. This loop is going to have only one if statement. And that's going to be if I that we define here is smaller than 2, or current number that we're going to loop through here, because we're going to be looping through our number. This is representing the loop that we have. So we're going to have a current number, and we're going to say if the current number is not equal to the number at the position of I minus 2, do the following. What's the following? Nums at the index of I should be equal to the current number, and then we're going to increment I. And this is basically it. We're going to return I at the end. That's all of it. Now, if something is a little bit foggy, don't worry, because we've still not visualized everything. So let's start with the visualization so you can actually see how things work. Okay, so when we actually start, we're going to define a variable called I, and this is going to be initialized to 0. Then we're going to enter this loop, and we're going to be looping through the numbers that we have here. In the first round, we're going to be looping through 0, as you can see. So we're going to be like, if I is smaller than 2, or, well, we don't need to check this because I is already smaller than 2. So this is true, and this is an OR statement. So because the first condition is true, we don't even need to check this one. So we're just going to enter this if statement, and we're going to be like, nums at the index of I is 0. So nums at the index of 0 should be equal to current number. Well, current number is 0. So nums at the index of 0 should be equal to 0. Now you might be like, well, we already have 0 here. So why are we doing this? You're going to see why when we actually come across a number that has been repeated 3 times. So for example, when we actually reach this position, until we reach this position, we're going to be acting normally, and we're just going to be putting the numbers in their own place. But when this happens, you're going to see what I mean. So we're going to put this 0 in this place, which is its original place, and we're going to increment I like so. So now I is 1, and then we're going to move on to the next round. In this round, our number is going to be this 0 that we have here. So current number is going to be this 0. We're going to be like, if I is smaller than 2, or, well, we don't want to check or because I is already smaller. So this is true. And then we're going to enter this if statement. We're going to be like, if that's the case, nums at the index of I, meaning nums at the index of 1, should be equal to current number, which is 0. So we're going to put the 0 in its own place again, and we're going to increment I like so. Now, in this round, our number is going to be 1. And now, I is not smaller than 2. So when we say if I is smaller than 2, this is not going to be true. So we have to check this part of our code. Now you might be like, why were we checking if I is smaller than 2? Well, it's quite simple, because we're allowed to have at most 2 duplicates. So because we're going to be in the beginning of our loop, we can allow up to 2 duplicates. We don't need to check if the number that we have is equal to the previous number or so, because until I is smaller than 2, that means we don't have more than 2 numbers. So we don't need to check if we have, for example, 3 repetitions or not. That's why. But when I is actually equal to 2, we have to check if we have more than 2 repetitions. So we're going to be like, is the current number, which is 1, not equal to nums at I minus 2? Well, nums at I minus 2 is going to be this number here. Why? Well, because I is 2. So 2 minus 2, that's going to give us 0. And nums at the index of 0 is going to be this number here. So we're going to be like, is 1 not equal to 0? Well, yeah. So we're going to be like, awesome. That means we don't have more than 2 repetitions. So we're going to enter this, and we're going to be like, nums at the index of I, meaning nums at the index of 2 should be equal to the number 1. And again, it's going to be its own place. So we're just going to put it back, and we're going to have this happening until we reach this position when we have more than 2 repetitions. And then we're going to increment I like so. And then we're going to move on to the next round. Again, same thing. We're going to be like, I is greater than 2. So this is going to be false. We have to check this condition. Current number is 1. Is it not equal to nums at the index of I minus 2, meaning this number here, because I is 3, 3 minus 2, that's going to give us 1. And this number has the index of 1. So we're going to be like, is 1 not equal to 0? It's not equal to it. So we're going to be like, awesome, we don't have more than 2 repetitions. So we're going to say nums at the index of I, meaning nums at the index of 3, because I is 3, should be equal to current number, which is 1, like so. We're going to put this one in its place again, and then we're going to increment I, like so. And now I is 4. Now, this round is really important. We're going to be like, if I is smaller than 2, well, it's not. I is 4. Or current number, which is 1. If this is not equal to nums at I minus 2, well, I is 4. 4 minus 2, that's going to give us 2. The number with the index of 2 is going to be, this is the number with the index of 0. This is the number with the index of 1. This is the number with the index of 2. So we're going to be like, is 1 not equal to 1? Well, actually, 1 is equal to 1. So we're going to be like, we can't enter this if statement because both of the conditions are false. I is greater than 2 and 1 is equal to 1. So both of these conditions are false. So we're going to be like, okay, let's move on to the next round. As you can see, I did not get incremented. In this round, our current number is going to be this one that we have here. And then we're going to check again. If I is smaller than 2, it's not. Then we're going to be like current number, which is 1. Is it not equal to nums at the index of I minus 2, meaning 4 minus 2. 4 minus 2 is going to be 2, meaning nums at the index of 2 is going to be this one that we have here. And as you can see, they are equal. So we're not going to enter this if statement and we're going to move on to the next number. As you can see, I is being left behind. And this is really important. Now that our number is 2, we're going to be like, if I is smaller than 2, it's not. Then we're going to be like current number, which is 2. Is it not equal to nums at the index of I minus 2, which is this one that we have here? Because this is the number with the index of 2 and I minus 2, meaning 4 minus 2 is going to be 2. So is 2 not equal to 1? Well, yeah, 2 is not equal to 1. So we're going to enter this if statement and we're going to be like nums at the index of I, meaning nums at the index of 4 is equal to current number, which is 2. Now that's going to make this number 1 here into 2. And as you can see, we're slowly getting rid of the number 1 that had more than 2 repetitions at most. Then we're going to increment I, like so. And then in the next round, we're going to be like, I is not smaller than 2. So I have to check this condition. Current number is 3. Nums at the index of I minus 2, meaning nums at the index of 3, because I minus 2 is going to be 3. That's going to give us this number 1 that we have here. Is 3 not equal to 1? Nope, they're not equal. That's awesome. So we're going to enter this if statement and we're going to be like nums at the index of 5 should be equal to current number, which is 3. Well, the number at the index of 5 is going to be this number that we have here, and this should be equal to 3. And then we're going to increment I, like so. Now I is 6. And then in the final round, we're going to check again. If I is smaller than 2, it's not. Then we're going to say current number, which is 3. Is it not equal to nums at the index of I minus 2, meaning nums at the index of 4? Well, nums at the index of 4 is going to be this 2 that we have here. Is 3 not equal to 2? Well, they're not equal. So we're going to enter this if statement and we're going to say nums at the index of 6 should be equal to current number, which is 3. That's going to make this be equal to 3. And then I is going to get incremented. Now I is 7. Now we're done with our loop. As you can see, our I is 7 and we're going to return I. And if we check, the first 7 elements in our array have at most 2 repetitions. As you can see, 1, 2, 3, 4, 5, 6, 7. Until this position, all of our numbers have at most 2 repetitions. And that's going to be it. Now let's code this in the simplest way possible. Alrighty, let's code this together. So the first thing that we need is going to be our I variable, just like we saw in the slides. And this is going to be initialized to 0, like so. And then we're going to have our simple loop. We're going to say for let current num of nums. And this is going to give us our number on each round because we're going to be looping through the numbers that we have inside of our nums array that's given to us. And each time the number is going to be equal to current num. So we're going to be simply looping through the numbers and we're going to be like, if I is smaller than 2 or current num is not equal to nums at the index of I minus 2, do the following. Literally just like we saw on the slides, we're going to say nums at the index of I should be equal to current num and then I plus plus. And then at the end, we're going to return I. Simple as that. Let's run this and see if we can actually get accepted. And moment of truth. Yep. And let's submit this and see if we can actually pass all of our test cases. Let's see. Yep, we got accepted. That's awesome. Thanks for watching. Don't forget to like and subscribe and keep on coding.